In this video, I'm going to talk about local and global maximum and minimum for a function. So let's say we have a function f that maps a domain D of real numbers to the real number line, let's say R. Now we are going to define the global max, global mean, and local max and local mean for this function. So let's start with global maximum. Global max or global maximum. Let's say C is some point in the domain D, okay, such that f of C is always greater than or equal to f of x for any x is an element of D. So C is such a point that f of C is always greater than or equal to f of x for any x in the domain D. If that is the scenario, we say f of C is the global maximum of this function f, and that maximum happens at point C. So that's the global maximum. Now similarly, we are going to define global minimum. Let's say D is some other point or some point in the domain of the function f, okay, which is D, uppercase D, such that f of D is less than or equal to f of x for any x is an element of D. If that is the case, we say that f of D is the global minimum. It doesn't matter which x you pick in the domain, f of D is always going to be less than or equal to f of x. So this is how you define global maximum and global minimum. Now let's go ahead and define local maximum and local minimum, or local max. So let's say we define local max. Again, we find a point C in the domain D such that f of C, okay, is greater than or equal to f of x. Now this time, instead of any x, we are going to talk about a neighborhood of C. So f of C is greater than or equal to f of x for all x in some local neighborhood of C. Of C. So if that is the case, then we say f of C is a local maximum, because f of C is greater than or equal to f of x for some small neighborhood of C, some vicinity of the point C. The easy way to understand this is just by drawing a number line. So let's say this is your point A and this is your point B, right? So let's say there's a point C right here, C. So if there is an open interval, so then let's put it this way, there is an open interval surrounding C such that any x you pick in this open interval, f of C is going to be greater than or equal to f of x. So it's a local behavior. So we call it local max. So this is the easiest way to kind of visualize it. So if the function is defined on the interval, let's say from A to B, C is a point in between, and you pick some neighborhood that is contained in the bigger interval AB and nearby C such that this condition holds true, then we call it local max. Similarly, local mean or minimum is, let's say D is an element of the domain D, uppercase D, such that f of D is less than or equal to f of x for all, okay, x in some local neighborhood, okay? So if this condition holds true for all x in some neighborhood of C, okay, some local neighborhood of C, then we say that it's a local minimum, okay? It's a local minimum. Again, you can go ahead and look at this diagram and see the number line and see how it works. Now, this is how we define global max, global mean, local max, and local mean. However, you can slightly modify this thing, by the way. So this thing could be modified by saying f of x is less than equal to f of c, right? Which are equivalent statements. Saying that f of c is greater than or equal to f of x is the same as saying f of x is less than equal to f of c. So similarly, f of x is greater than or equal to f of d here, which are equivalent statement, and similarly here and here. I hope that this discussion was helpful. Thank you very much.